Thanks, Sean. It is always a pleasure for us to come here. So we are Residential Engineering Solutions. We've been in the same apartment office for, I think, pretty much our entire existence. The company's been around since 1990. We are structural engineers. We are forensic structural engineers, and we investigate houses. You know, we follow you, and we are so happy that we can follow you. And we actually rely on you to do that first pass, to find and weed out those structural issues, and to weed out the things that aren't major structural issues. And we love following up on that. In fact, I was telling Bob earlier today, you know, for the past 2 years, we've been receiving a lot of phone calls of people that call us and say, hey, we skipped the home inspection. We had to buy the house, or the market is what it was, or we had to close, or the seller was being, whatever the reasons. We skipped the home inspections. And now we need a structural engineer to look at everything. I turn them away. I say no. That's not for me. I say no. Go back to your home inspectors. And actually, what we say is go to ASHI. We always recommend this organization to everyone that calls us with that. They say this is the group. Go to their website, macashi.org. They're your first pass. They're your first stop on this process. See what they have to say first, and then come to us. And that's what we love. That's what we like. And we work best when we have this sort of feedback first to go on. I was also telling Bob earlier, he's the only one that emails questions and photos to us, and we love answering it. We love answering those. Like, oh my God, this is hideous. This is not right. Wow, this is great. Absolutely, this is not right. Let's do something about that.
And I'll add something to that. I tell my clients, I don't necessarily know what's right or what's wrong, but I know what I'm looking at isn't right. I don't know how wrong it can be. It may be something new, but somebody who has more initials after their name than me needs to either bless it or fix it. And what I'll often do for all under time constraints is I'll write my report, I'll call out for further investigation. At the same time, I'll send a picture to these guys. Hopefully, I'll get a real simple, you're right, Bob, that's not right. Somebody needs to look at that. And if I can, I put that in my report. Now, my client has a little bit more information to go front somebody, whether it's a builder or somebody. So these guys are great. And send them pictures. You might see your picture up on the screen because it helps all of us. Sorry.
No problem. I appreciate that.
Coffee?
Yeah.
Coffee, dinner?
Exactly. I do have to apologize in advance. Somewhere between the car and here, I have misplaced all of my business cards today. But I'll be happy to share our website. It's www.resolutionsdc.com. Or it's also, I think, res-dc.com gets you there as well.
I think we have that on the website. It's on the calendar on the website.
Excellent. Thank you. All right. So today we are discussing structural issues in renovated houses. What happens when you change a home? What happens when you take a house structure and turn it into something else, or something has changed, or something has been affected? Who here recognizes this house? Probably the most famous renovated house in the country. Yes, it's the Winchester House in California. Over 160 rooms, built between the late 1800s and the early 1900s. She kept adding and building and adding and building up, building out, back. There's rooms without floors. There's rooms where the staircases go to nothing. It survived the big San Francisco earthquake at that time. So there's parts of it that have earthquake damage. I've never been. I would love to go. I would love to go. I mean, this to me is everything. It's been renovated a zillion times. It's suffered structural damage. There's parts where the structure is exposed. There's parts that, I mean, it's a mess. I would love to see it. I would absolutely love to see it.
I think the closest we have around here is the mansion on Hope Street in DC.
It's funny, I just heard about that. Yeah, like all the secret passages and whatnot. It's on my list for next year. So back to the DMV. So today we're talking about a number of different things. You know, in general, what does it mean when you change a house? And then what happens with an addition? What are some of the problems or behaviors associated with additions? What happens if we change a space in or against a house? And then finally, what happens when we start to excavate things as part of renovations? So starting with changing a house. So for those of you that saw my presentation last time a few years ago, I was talking about expected behaviors in homes. How do we expect the structures to behave? You know, a house is a living, breathing thing. It shrinks, it sags, it creaks, it groans. The best way I can describe it is a house, as a house ages, it gets used to the things in it. There's a bathroom on the second floor. It's been there for a few decades since the house was built. Well, the house starts to get used to that heavy mass being there. Go to a 100-year-old DC row house, everything on that second floor slopes down towards that bathroom because it's this heavy thing that's been there for a century. And the older a structure is, the more of these expected behaviors are present. You know, the floors have a nice sort of draped effect over the bearing walls and beams below. You know, the kitchens are the low spots. So wood deflection, the engineering term for that sagging process. You know, wood joists, wood beams, wood posts, wood everything. It's made out of plant fibers. As a beam or a joist is loaded just from usually the weights of the finishes, the fixtures, all the dead weights, the wood fibers on the bottom actually stretch and the wood fibers on the top compress together. I can go in a home, I can measure a piece of lumber, I can guess what species it is depending on when it was built, and I can sit down and calculate how much it's going to deflect over time. And the code allows for that. The code says, okay, the current code, you know, you've got a 20-foot span, it's allowed to deflect 20-foot span. It's over, the deflection is the span over 360. So, yeah. So I can't do simple math. I'm an engineer. I apologize. But you know, it usually ends up in the order of 1/4 of an inch to an inch to an inch and a half for very, very long spans. That's accepted. That's acceptable. And that's current codes. You know, 100 years ago, we didn't have that. And that wood, that 100-year-old lumber, 100-plus-year-old lumber is still stretching. It's still sagging. It's still deflecting today. There's things in a home that exacerbate that. Again, rooms with heavy fixtures and finishes, kitchens, bathrooms, tile, tub, toilet, pipes. Yes, fish tanks, built-in bookshelves, like all of those fixed heavy things or even movable heavy things, that really exacerbates that long-term deflection. Staircase openings are another big factor. A staircase opening is it's a hole in the structure. There's, in theory, beams and doubled up joists around the stair openings. That deflects more because it's a staircase, because we also use it. It sees a lot of foot traffic.
Does deflection apply to live loads or head loads or both?
Both. Good question. An interesting phenomenon with wood, which is different than any other material. Wood has less resistance to dead loads than it does to live loads. So when you're talking about a steel structure deflects elastically under all loads. So you load a steel beam, yes, thank you, hopefully. You unload it, it bounces back. You load a wood beam with dead load, it creeps and keeps stretching. And dead loads are actually much worse for wood structures. Wood structures actually fare very well, again, shorter the duration loads, rain, snow, wind, earthquakes, because wood is stretchy and it's springy. It does not tolerate dead static weights, which is why dead load deflection is usually the long-term behavior that tends to happen in structures. So again, those heavy rooms are really the factors because it is dead load. But yes, live load, there is live load deflection as well, but because wood is so springy, it doesn't affect it as much. So here is photographing deflection is impossible. But here's a great example. You can't really tell from the photo, but the door frame is askew this way. That whole wall is curved this way. There's a bathroom right behind that door. This is a great classic example of an expected and normal behavior of an aged wood structure. We have a bathroom, we have the wall, which is heavy. So as the house ages, the door frame goes with it. This one, I think, had been shaved down on top over the years to sort of keep fitting in the door frame. But this is normal. This is a normal and expected behavior of a wood structure.
Are you saying that wood structure from that dead load, once it's deflected, it doesn't come back?
That is a great question. It doesn't come back as much. If you completely unload a wood structure, it does spring back, but it doesn't spring back 100%. It has a permanent.
So that's deformed.
Yes, exactly. That's a permanent, and it's a plastic deformation. It has a permanent stretched plastic deformation in it. So it will never spring back 100%. That's the biggest downside of wood structures. Steel, again, under normal circumstances, steel doesn't behave that way because it is almost a fully elastic material. When you unload steel, it should spring back all the way. If it doesn't, then there was a larger problem. But yes, wood does not spring back completely.
Saying that plastic crack over the door is not necessarily structural.
Yeah. Absolutely.
After calls are for that.
Yes, that's right. Yep. And that's actually one of the reasons why I say, hey, you should not hire us to tell you that you've got a non-issue. Yeah. You're right. Half of our calls are, oh my God, there's a crack above the door. What are we going to do?
Would ever reach a maximum deflection and then stop, or is it 100-year-old house and then 150 years is still going to be deflected?
It reached, well, that's a great question. I don't know if I have a good answer to that. It slows down to a point where we can't measure it anymore. Could the argument made, has it stopped? Sure, effectively. Yeah, effectively.
For all practical.
Yes. Now, that same 100-year-old house, we leave and we come back in 50 years. I bet it would feel perceptibly different. I bet it would feel worse. But we can't measure that anymore. So I think there is a point where the fibers have stretched as much as they can, and then that's it. The flip side of that is I have not seen deflection turn into failure. I've never seen those wood fibers snap on their own. They snap for other reasons. They break for other reasons. knots, imperfections, fire retardant chemicals, things of that nature. But I have not seen deflection by itself cause a failure of the wood.
Does, old wood deflect less than new wood?
Oh, okay.
Old growth.
Old growth versus new growth timber?
New growth, yeah.
Yes.
Yes.
Yes, but here's the issue. The old wood has had longer to get to that point. New lumber deflects so much faster because it's greener, it's wetter when it's harvested, it's grown fast. Yes, 100% new wood deflects faster. So I think there will be a point out there in the world in which new structures will catch up and then possibly bypass older historic buildings with their deflection problems.
Even those with engineered lumber like I-joists?
And there's the difference. There's the big difference because we engineered I-joists, we eliminate the wood fibers. We eliminate a uniform piece of a tree stretching out. Now it's a layer this way, a layer this way, a layer this way, glue, all the other bits and pieces. Yes, engineered joists behave so much better than traditional lumber. And there's the exception to that. Now, they still deflect, but we actually don't really have enough long-term data on that yet. Does it deflect plastically and stay stretched out? What happens when we unload it? We don't really know yet. So about, does deflection keep going? Does it eventually stop? Again, it goes into an imperceptible amount until as soon as we make a change, any change, we strip the finishes in a room and we put new finishes down. The wood will spring back some amount, but then it'll start all over again. We change a room, and I'll get more into this later. We add a bathroom where none was before, and we don't do anything with the structure. Now we've added a whole lot more heavy stuff that's going to really exacerbate and accelerate that deflection all over again. Other changes, again, those changes, we change of space, there's normal expected things, and some changes do cause structural problems, no question. We add, going back to a bathroom example, we can overload the structure. We can fail the structure by adding too much weight on it. Then if the structure cracks, okay, well that's a problem for too much weight. But maybe you don't just not overloaded enough, but then that deflection gets really significant. Well, is that still normal? Is that still acceptable? Maybe, because there's a heck of a lot of gray area in between.
Let me just real quickly, our audience, our online audience is having a hard time hearing the room.
Okay.
If you could repeat questions, we're getting a couple people are requesting to repeat the question.
Sure, no problem.
We're talking about, like, the photograph you had where the door was sagging or.
Yes.
Or all that. We're talking about like a 100-year-old house.
Yes.
So if we're stripping the house out and wasn't the back of the plaster and wasn't the mud set tile always heavier than what we're going to put in now? If we're going to put drywall, it has to be lighter than that. We're not going to use mud set tile. We may put another tub in, but those old cast iron tubs are pretty heavy. So are we overloading a renovated house?
Great question. So the question is, if I were to summarize, if you renovate a bathroom, for example, with lighter, more modern day materials, What does that, how does that affect things? To some degree, even though we're switching the materials to something lighter, you are still restarting that deflection process to some degree. It's hard to predict. I suspect that the short term will see that deflection process start again, but in the long term, it'll slow down faster, if that makes sense.
Would you recommend if you were renovating one of these older row homes, just say that, 'cause we see a lot of that now. Would you recommend that they're using the same wood floor structure? Recommend trying to jack it up or support it? Or would you recommend leaving it like it is and then like putting tapered pieces on top of that, or just leaving it the way it is?
So the question is, what would I recommend for a deflected floor if I was renovating? Would I push it back up? Would I add material on top to level it out? I would recommend adding material on top to level it out. I am not a fan of trying to push a structure back into place. And the reason is time. It's taken, again, talking about a 100-year row house, it's taken a century to get to that point. If we then push those plastically deformed wood fibers back into place in a day, 2 days, that is going to cause a lot of damage, because those wood fibers are stretched in a way that's taken a century. We don't want to push those. We don't want to compress those back again. That can cause a lot of real damage to a wood structure.
Let's see, sister joist to get a floor back level.
Yeah, sister joist to level floor. I'll be touching on that later. Absolutely, 100%. So the other thing to note is positive changes in a house can cause cracks. So changing a bathroom to lighter finishes, stripping the plaster and the lath and the ceramic tile and putting something, I don't know, putting hardwood. I see a lot of hardwood bathrooms these days. Much lighter materials, much lighter everything. The house is going to react a little bit to that change still. So I've seen people we've had people call us like, geez, Matt, we just got a whole new super efficient, super amazing insulation in our attic. Our heating and cooling bills have dropped. Why in heaven's name is all of my ceiling cracking? Because you changed it. You've changed the behavior. The house, I hate to use this word again, the house got used to behaving one way. And now it's behaving a different way, a better way, but it's different, it's changed. So the house will react. So before I move on to, I guess, additions, any more, and I'll be covering things like sister joists, like reinforcing structures. I'll get more into like changing interior spaces later, but any specific questions on, I guess, deflection and expected behaviors in a house?
Is there something about lightening the load on wood that's been deflected, lightening the load, it comes back up, and then putting more material and coming back down? Is there something negative about that, just that action of undeflecting and then redeflecting?
Is there something negative about undeflecting and redeflecting?
I don't know how to.
Yeah, I mean, I don't know how else to put that either. I would say not generally.
I thought that was what you were getting at, was that was a problem, that was negative, so it's not an issue.
It's not an issue unless you forcibly
Right.
undeflect it.
Okay.
Letting wood continue to do its thing is usually perfectly fine. Yeah.
So we have a question from the peanut gallery. Mark Lunder wants to know, how can changing or improving site drainage cause problems? Is that a little bit off topic, or?
I'll be getting to that later, but I can mention it. No, I take that back. I don't think that's later. This is a perfect question. This is a great question. Our soils are terrible. They are terrible clays. They get wet when they expand, and they liquefy when they get far too wet, and it causes all kinds of problems. It's funny, I just had a client that I'm doing a crack monitoring service with. So a year and a half ago, I had a client call us, major cracks on the side of their front porch. Right on the side of the front porch, there was a downspout pouring right there. And I think they even had like a stone wall keeping it all in. And so my recommendation was, okay, well, you know, we can do a crack monitoring service. We can come back, we can install devices on the things. But before I do that, can you just get this out of here? Fix this. Buy this stupid extender, put it on the downspout, and he was this far from the side of the hill, pour it down the hill. Since he did that, the cracks have actually closed up ever so slightly. With the way our soils are, when they dry out after decades of being soaked and expanding with decades of downspout discharge, they can contract again. So yes, there can definitely be positive changes in a home from correcting site drainage, positive foundation changes. I've seen it, I've measured it. I've never thought I'd be able to measure it, but I did. And it's fascinating. And I was so pleased to be able to tell that client. Well, and I told him, hey, the cracks are getting smaller. And he looked at me, he's like, what is that possible? It's like, well, did you fix the drainage? It's like, well, yeah. I was like, well, yes, that's possible. 100%.
I think what's also an issue is that most homeowners have no clue what a load path is. And I remember the house we did together that had the addition where they put in a spiral staircase. And that's a heck of a concentrated point load. And I took a picture of my client standing in the basement directly below where it was, and there was nothing.
Oh no.
So, yeah, that was, they don't know, and they don't know to ask those questions.
Right.
You're talking about row houses. Have you ever had any clients that want a clear story in the row house? They want to remove the second floor, make it this big open entryway and all this stuff. Do you have any advice about doing something like that to your own structure?
That's a tricky one. I have not had that request for a row house.
The question was, do we ever get clients asking us about opening up a second floor or removing an entire floor system in one of the city row houses that are 100+ years old?
We've had that request before in wood structures, where people wanted to like open up their foyers. You know, they can go in a house. Now they want a 2-story vaulted foyer. There are structural implications of that because the floor system braces the wall. And if you take out the floor system, the wall now has a hinge in it. So without that floor deck, without those joists engaging it, you create a hinge in the wall. It can create a real problem. So we designed solutions before where we somehow have to fix this hinge in place. It is not intuitive. It is not easy. It is not cheap. And we did, I remember years ago I did one. I forget how tall the wall height was, but I think we ended up putting like 2x8 wall studs, like full height, because the wall was so tall. And so, you know, it was just 2x4s. I was like, can't do that. So with row houses, it is trickier because now you have brick walls. Oh goodness. And on top of that, the floor joists are usually not engaged well in the perimeter walls. A lot of times they're just loosely sitting in pockets. Maybe you'll look out and there'll be, the star bolts and the ties to the floor, or some of those really old like iron straps and anchors holding them in. But a lot of times, particularly with older row houses, you just have joists loosely sitting in the wall, and the wall itself relies on its own mass to keep from being floppy, for lack of a better word. I don't have a good answer for that. I don't know how I would do that. off the top of my head.
Standing unreinforced.
I'm sorry?
The masonry walls are standing unreinforced.
They are.
By gravity.
They are. And they rely just on that to be stable. Yeah. The secondary part of that is if there's ever an issue with that masonry wall, if there's a little bit of foundation settlement or cracking, now the wall has moved in addition to being unbraced. And now that's just a whole slew of problems.
In an older house, what do you feel too much deflection? When is there too much floor deflection?
Ooh, when is there too much deflection in a house?
And things are starting to pull out of pockets.
That's a good answer, yeah.
I've seen
Or
it a
the
couple
china
times.
rattles too much when you walk by it.
Yeah, too much deflection. Yeah, the joist can start to pull out of the pockets.
But you can't always see that.
Right. Right. I look for corroborating evidence like the flooring versus the baseboard trim. Is there a gap there? Can you see the line where the baseboard used to be and now it's pulled away, and you can see the flooring, like the shadow of the quarter round on the floor, things of that nature. To me, those are signs that I look for, like, okay, this is pulled away enough. How much bearing was there originally? How much is there now?
So it's not the bending, it's the bearing.
Correct.
Most of those row homes have had that parlor wall taken out. That's perpendicular to the second floor joist.
Mm-hmm.
They're like, what did they do up there?
Yeah.
The bearing wall. They just take the thing out.
Indeed. Yeah. That wall down the middle of row houses that's taken out. I'm actually going to touch on that one later when removing walls, because there is a little bit of gray area there as well.
I think a lot of the guys here may not understand that when it comes to conventional framing floor joists, whether it's a 2x6, a 2x8, a 2x10, there's a lot that goes into the designing of the clear span that these pieces of wood can take. If it's hem fir, if it's yellow pine, there's charts on all this kind of stuff. And you need to get involved in that if you're looking at an underside of the floor. You can't just say, hey, this floor is sagging, but why is it sagging? Well, you don't know what kind of wood it is. There are also the ends of the wood are called, years ago they did what's called fire cuts. Where they would fire cut the ends so that when the house burns, everything falls in rather than goes out.
I love fire cut joists. It's my most favorite morbid fact. I mean, it's terrible. I mean, it makes perfect sense. You have a city with super densely populated homes. The fire breaks out in one. Okay, well, let's smother the fire, deal with it there, and hope it doesn't spread. But yeah, today absolutely we have the IRC has floor span tables. Okay, you've got this span, it's this joist, it's this spacing, and the IRC is designed that anyone can pick up that book and build a house from it if you follow the tables in the book. But that's what it's there for, and that's actually a great resource. Those tables, those charts. There are exceptions, and that's usually where we come in. Now we can really sort of fine tune that. We can tweak the species a little bit. It's rare, but occasionally we'll say, well, 2x10s don't work for this span. But instead of hem fur number 2, if you use hem fur number 1, you can go this far. So there is a lot of nuance to that. But the IRC, all those joist span tables, that's a great resource for that. And those tables account for the predicted deflection of those joists and those species of wood. It's all built into it. I think the IRC tables are a bit bare minimum, but they do meet those deflection limits. All right, moving on to additions. So when we talk about additions and issues with additions, I'm going to be talking about a couple things. When you have sort of a construction style or a mass or a construction type difference between the original house and the addition, or what happens when the addition is all glass or has a different HVAC zone or no HVAC whatsoever, and someone just cut a hole and put a pipe there. Oh, that's our cooling. And what happens when we have an addition built on backfill, or more simply, a lot of times it's just an addition built right up against a house where a basement exists. Sometimes it's as simple as that. So whenever you have, again, an older home and a brand new addition, there's going to be different materials. The lumber is going to be greener. The lumber is going to be newer. The materials are going to be different, either better or worse. They're going to be different. So we have an old seasoned structure that's already deflected and has possibly slowed down, and now we build something brand new next to it. That new structure, that new joist, those new beams, they begin their own deflection process. So you get things like this. Now, admittedly, there was also the rear foundation wall of the house was also under this law. And the I take that back. The joists were actually installed fine. There wasn't a visible problem with the wood structure. The joists on this side were spanning this way. This dip in the flooring was at the worst of the new deflection. But we had this massive unmoving foundation wall next to it. So this was a great example where this brand new structure did its thing, and because of the location it was built, because of how the existing structure was at that spot, that deflection happened to be the most perceptible, had to be so significant that it ripped through the floor. There were no cracks, there were no failures, there was no crushing of anything. The joists were spanning a bit longer than I would have liked, but it would have still been code acceptable if I ran the numbers. I see this a lot. I see this mostly when we have tile finishes that sort of bridge that gap between the original structure and the sunroom that's out back. After a year or two, there's a nice straight crack right along that interface. Well, because the original structure back there has done its thing, but the new structure is starting to deflect. Or I see the flooring crowning over that level, because the joist here deflecting this way, the joist here deflecting this way, and the high spot, again, is over that support element that's not going in.
Flooring looked up as though the door threshold leaking. Water. Is that an outside door?
It is not an outside door. It was an interior door.
Looks like that.
Yeah, right. It was right smack in it was a weird floor plan. It was right in the middle of like the addition. Yeah, completely interior door. So we get to similar situations when we have an addition that's all glass or doesn't heat or cool well. Well, now we have a box attached to a house that just flexes differently from changing temperatures than the rest of the house. Going back to a 100-year-old row house, they're solid brick boxes. And we've got a little wood siding box tacked onto the back. Well, that flexes and breathes and heaves and shifts so differently than the 100-year-old brick box it's attached to. That interface, I see so many cracks. This is a terrible picture. I see so many cracks where those wood-framed walls meet the plastered over, the drywalled over solid brick wall. Because those wood-framed siding walls are flexing like modern construction flexes. And that 100-year-old brick house is not. So that whole interface sort of between really old structures and new additions tends to see a lot of normal and not really structural issue cracking just because it's a different construction style.
So is there anything that the contractor can do to minimize the cracking at the juncture of old and new?
That's a great question. What can a contractor do to minimize the cracking at that interface? Cover it in trim. Put flexible joints. If we know it's going to happen, we can plan for it aesthetically. And that's really the best bet, is if you have construction styles that are that dissimilar. There's not really a good internal or structural solution to that. I see a lot of, I recommend trim a lot on the wind. I'm not talking about roof truss heat here today, but roof truss heat is something that we see a lot. Roof trusses, I mean, they do their thing. They bounce up and down, nail pops, cracks, and all that stuff. People call us like, oh my God, what do we do? My ceiling on the second floor keeps cracking year after year after year. It's like, have you thought about crown molding? It's lovely. And you won't have to think about it anymore. Okay. Moving on. Oh, yes, Bob.
Crown molding many years ago was designed specifically to cover that crack,
Yes.
and it wasn't putty top and bottom, it was putty on the top only.
Yes.
It was meant to move with the ceiling and cover that crack.
Absolutely. Yeah, 100%. Crown molding, only with one fixed joint on it that lets the stuff slide up and down. Absolutely. I tell people that today, they think I'm nuts. But yeah, it's a great use for the stuff, and that's what it was for. So moving on to additions built on backfill. So a lot of additions that are shallow founded, so slab on grade additions on crawl spaces, they run into trouble when you build it attached to a house that has a basement, that has a deeper foundation. And a lot of times the only reason is because the house has a deeper foundation. This also applies to like porches, HVAC pads, anything shallow with shallow foundations, heavy, built next to a house with a basement. I have a diagram shortly, which makes a lot of sense. So we have an example, house in Tacoma Park. It had a rear addition on the back. House has a basement. The addition does not. So on the outside, big, nice V-shaped crack. Real nice, clear evidence of, foundation movement, of basically the addition sinking off, pulling away from the house. What's happening is we have the main house, which has a normal basement. The original, even though this house was, in the 1900s built, the original overdig for the basement is this big wedge zone around the perimeter of the house. They were filled with backfill. And now, even years later, we come in and plot a structure on top of that with shallow foundations. That addition can then start to move into that space for no other reason than that basement exists. That number, that zone, is about a 45-degree angle from the bottom of the basement footings. So you have a 7-foot tall basement. The footings, in theory, if they hopefully exist, are about 10 inches, let's say a foot below that. So you get a 7-foot tall basement. There's an 8-foot wide zone around the entire perimeter of the original backfill, more or less. Yes.
Is that settling, putting added pressure lateral load on the basement foundation wall?
Excellent question. Is the settling putting additional load on the basement foundation wall? It can, and that depends entirely on how the addition was constructed. So if the addition's footings are out here, so if we've got like floor joists like over a crawl space, for example, and a shallow foundation wall here, it's probably far enough away that as that moves down, it doesn't apply pressure. However, if this were, say, a slab on grade addition, now we would have this whole solid mass of concrete consolidating the soil. Absolutely, that puts pressure on the basement wall, no question. Front porches, patios, stoops, as those settle down, those push in as well. I see a lot of settled front porch stoops, and then just inside there's a nice horizontal crack in the foundation wall right under it. So absolutely, it can.
I mean, you'll get that in like downtown Frederick, the old houses that used to be horse and buggies going on Market Street and all of that, and now you've got semis. So you're getting an awful lot more heavy loads being delivered to the foundation walls, and those houses are like maybe 6 feet from the road.
Mm-hmm. Yeah.
How long does a disturbed soil take to come back to like a disturbed soil?
Depends on the site drainage. Oh yeah, and the type of soil. Yeah, how long does soil take to fully compact and not yeah. I don't have a good answer for you. In theory, no, not in theory. This was in the 1900s house. I forget when the addition was built. I would have expected the soil to have fully compacted by now and this not be an issue. Decades later, it shouldn't be an issue.
So several decades, one would is a fair assumption that it's compacted back.
Indeed. Now, as soon as we introduce poor site drainage into that, though, we have downspouts in the back of the main house at that spot. I mean, all bets are off. John?
Would that depend on the, how the backfill was installed, if it was compacted properly and things like that?
Yes, would that depend on how the backfill was installed? Yes, if the backfill was compacted as they did it, that would have been great. I've not seen it yet. I honestly have not seen it yet. And when occasionally we'll specify. No, I think that's in our typical structural notes, compacted backfill. You have any idea how many angry phone calls we get? What do you mean I have to compact the backfill? Are you nuts? It's like, I haven't seen it yet. And we require it on drawings, and it is blatantly ignored.
So right up against the foundation, you compact backfill.
Yeah, you have to be careful about that because of that. Yeah, we recommend getting a geotechnical engineer involved that can advise more on the specifics of how to do that right. Because there is a right way to do that, and there's a lot of wrong ways to do that that introduce a lot of pressure and major problems on the foundation.
So just hypothetically, if this was your addition that you were going to put on a house, would it
well, whether it creates all costs or not, but would it actually be cheaper to just put a basement underneath that addition versus go through all the additional, whether it be pilings or structural lists of compaction and?
Sure, good question. So if it was my addition, you know, would I just build a basement or or a different compaction? I think there's somewhere in the middle. I think there's a place where we can put foundations out here, which are slightly, it doesn't need to be much, but slightly deeper than the normal frost footings that get us out of that presumed backfill area. So, I mean, a full basement would be great, but sometimes it's as simple as, hey, our frost footings are 2'6", well, let's go 5 feet. Let's look at the geometry. If we go 5 feet deep, we're far enough away from the house, we are probably outside of the backfill and overlay. So I think there is a reasonable, rational point somewhere in the middle.
And the farther you go away from the house, obviously, the less.
Right.
Yeah, does this exist in the gable end and the eve end? Yeah, it does. I think it's usually just a function of the footprint. We've sometimes spec'd a limit of excavation on when we issue drawings for foundations. We say, okay, your over dig is limited to 3 feet away. Those are great fun. But you know, trying to limit that as well. There is, this is a very, very generalized everything. I've seen the over dig in the backfill zone to be much larger, to be not this nice happy triangle. I've also seen it shorter. It also varies on the quality of the original soil when they were digging too. Maybe the soil was nice and stiff for that week, and they were able to, you know, cut this nice steep angle. But I find that this is usually around the entire perimeter of the house to some degree, but it does vary with grade. So if you have a high grade here and a walkout basement here, in theory, at the walkout basement, the foundations are only frost depth, so the overdig is only a few feet. So it's really not an issue for something like that. It's all, well, it's not all. It's mostly geometry, some voodoo with the soil, but it is pretty consistent around the perimeter. Interestingly, this also happens inside the basement too. I see it more in new construction where I'll see a basement slab will have this nice perimeter crack right around, maybe a good, 2 feet in from the perimeter walls. Well, there's a little bit of backfill right there. And if they didn't put mesh in the slab, they didn't put whatever in the slab's not thick enough, that can happen on the inside with newer construction too. Well, I guess it could happen with older construction, but for some reason I don't see it as much with older construction. So this house, we had actually recommended underpinning. So this was at a point where, well, there was evidence that it had been pulling away for years. There'd been foundation settlement for years. We felt that this is not correct site drainage and walkway. This is, okay, there's been a lot of movement. We need to stop it and move on. I mentioned it before, but I noted it. In retrospect, if those footings at the far end of that addition were just a little bit deeper, it would have probably saved a lot of movement, prevented a lot of movement, and things would have been in a much better situation. So here's another great example. This one I just saw a couple months ago. This was a house in Rockville. Lovely addition on the front of the house. Absolutely lovely. This gorgeous, like angled front door. The main house has a normal basement. The front addition had a shallow crawl space. So we got a call because she's like, oh, there's cracks in my stairwell. What's going on here? So on the inside, there were very clear V-shaped cracks right where the addition met the main house. The addition was just pulling away, settling downward. On the outside, we found the same thing in the opposite corner, the nice front entry too. The trim was separating from these big decorative piers. Very, very clear evidence that the whole front addition was just, the footings at the edge were sinking, the whole thing was pulling away. What I don't have good pictures of here is the floor joist of the addition. They didn't use hangers. They put a ledger on the foundation wall. They toe-nailed the joists into the ledgers. All the toenail joists were just tearing out of the end grain of the joist because there was so much movement of this structure.
And did you ever find out, was that addition built with permits and inspections or not?
Was that addition built with permits and inspections? Yes, it was. It was. So my guess was that if the footings had just been, again, a hair deeper at that front edge, it would have saved a lot of damage and distress. So I believe that this was constructed per code, per permit, and everything correctly, but they just didn't account for that zone of backfill. They just put, hey, we're far away from the house, we just need frost depth footings, and that's it. And it was acceptable to code, it was acceptable to permits, the designers thought it was fine. Everything on paper was 100% correct. And now she is underpinning her house as well.
Whose fault was that?
Ooh, whose fault was that? Oh my. Wow.
Mother Nature.
Oh, yeah. Yeah, because it was right. Like it was, yeah, thanks Todd, whoever has the worst lawyer. Wow. Whose fault was that? I mean, it was by the numbers, it was per code, it was permitted, it was stamped, it was sealed, it was designed right.
I mean, did you dig down to know how deep the big part of the underpinning to know that it was to the right depth?
We haven't got to that point yet.
So we don't know.
We don't know. I would love to find out once we get to that point.
But isn't the lack of hangers, how old was the addition?
Roughly. 2013, yeah, 8 years.
Wouldn't hangers have been required? Isn't that sort of catch your attention that something's not right?
What was? There was something. The framing in the crawl space was odd for other reasons. There was actually a steel beam very close to the face of the house. They'd actually support them, which was weird. The joists were spanning front to back. At the front edge, they were on the foundation walls. Then they spanned to a steel beam, which was only a foot or two away from the foundation wall of the house. So my guess is they designed them to almost like cantilever towards, which is weird, but okay. I mean, it's strange. I wouldn't have done it. Again, structurally, if I ran the numbers, did everything, I think would have been right. I would have never done it that way, but you know, to each his own. It was weird. I hope that, and I tell Kyle this a lot, you know, the more house structures we design, I like to think that we are designing ourselves out of future work. I don't want to do this. I want to be the one that yells at the contractor, no, you put those footings at the face of the house down 5 feet instead of 2'6". I don't care if you don't like it. I don't care if it's a few more courses of block. didn't do it. And hopefully then we don't hear about this house 8 years later when this stuff happens. I think I lost your question somewhere in there.
got it.
Okay, great. Thank you.
Can you hear me?
You said block, is there any difference between poured concrete, which is what we see mostly in modern foundations, and block, which is more additions and probably 25 years ago?
Is there a difference in foundations between concrete and block? I like concrete better because this is a weird, that's not a weird reasoning. This is my reasoning. I find it easier to convince builders to reinforce concrete properly. My experience with block walls is that it's not reinforced enough. It's not grouted solid enough. You know, an 8 foot tall, 8-inch cinder block wall needs a lot of reinforcing in almost every other, if not every cell, to resist our stupid clay soils around here. I think concrete weathers better and lasts better. From a structural standpoint, and we can design either one just as easily. For reasons that I still don't know why, like you said, additions tend to be block foundation walls and new construction tends to be poured concrete. No, poured concrete's faster. That's why. It's faster to bring out the truck, put up the forms, fill it up, rip off the forms, and move next door to do the next house in the development than it is for a mason to sit and do that. Whereas for an addition, you don't want to bring out the concrete truck if you can have some guy just put the Legos together.
So there's a big expense difference.
Yeah.
Also major.
Yeah.
Because damaging the ground when you bring the trucks in, you bring the pump in.
Yep.
Versus, block.
Logistics, to build it in the backyard.
Yes. Yeah. Absolutely.
Or out in the woods.
When do you use a 10-inch block versus a 12-inch block?
My cutoff is honestly about 7 feet. No, I'm sorry, 10 to 12. I take that back. My cutoff for that is 8 or 9 feet usually. And I usually put the question back to our clients because I can only fit a certain bar size in each block. Like a 10-inch block at max, you don't want to go bigger than like a number 6 bar. I mean, that's a huge rebar, but any larger than that, and you don't get enough concrete cover around in the cell to make that work. So when I design a basement foundation wall, I try to give people options. Like, okay, if we go 10-inch block, we need 6 bars every cell. But if we go 12-inch block, we need 5 bars every third cell. You know, which way do you want me to go? I don't know if I have a good answer. Because there's options there.
Isn't that governed by how much backfill
Yes,
there is?
that is
behind
governed.
both side block?
Yes, that's governed by how much backfill, the height. Yeah, how much backfill, the height of the grade. To a lesser degree, the size of the house on top affects that as well. But it's usually just the height of the grade, the how bad the soil is at that spot. That's what almost the only thing that governs the thickness of the block, the reinforcing of the block.
So in a poured concrete wall, just say it's a 9-foot wall, you're putting a mat of steel in there
Yes.
vertically,
Yes.
and then the concrete foundation companies pour the wall from the top, right, with the pump.
Yeah.
Well, it's separating the concrete aggregate as it's going through the rebar. So wouldn't you recommend filling the wall from the bottom up with the wall pipe?
That's a good question. Okay.
You never see it.
No, I never see it. You know, would I recommend filling a poured concrete wall as we go, basically, instead of all from the top? I mean, I'm for really large and thick concrete foundation walls. I recommend the concrete vibrators for that, to really mix that back up as they're going. So we don't have the separation of the aggregates. So we don't have air pockets and all that other stuff that happens.
And that needs to be monitored also, because the vibrator will separate that from knowing.
Indeed, yeah.
It'll drop that aggregate right to the bottom.
This is also true, yeah. So there's
Should it be vibrated from the inside of the form or outside?
I really don't have a good answer for that question. Yeah, I really don't have a good answer to that question. I will say with house construction, with residential construction, it's usually not as much of an issue. Here's our little trade secret here. When we design concrete foundation walls, we actually design them as completely unreinforced. And then we put a steel, the steel reinforcing in it anyway, so that in case it does not properly engage, it has enough thickness that it doesn't matter.
You don't even put temperature steel in it?
No, I do. That's what I'm saying. We design it, we check it to make sure it works as if there's zero reinforcing. And we put 4s of 12 each way in.
Vertical bars?
Mm-hmm. Yep.
Because they didn't do that so recently.
That's correct. They did not do that till recently.
It was 3 temperature bars of steel in there, and that was it.
Mm-hmm. Yeah, so we cross our T's and dot our I's and make sure the concrete works without reinforcing, and then we reinforce it regardless. The great thing about concrete, and actually, Bob, this goes back to your question, a big functional difference in concrete versus cinder block walls is where we can put the rebar. With a block wall, we really can only put the rebar in the middle of the cell. With a concrete wall, we can bring the bar closer to either face, and that actually drastically increases the strength of the wall. So how does that work? If a concrete wall bends this way, you want the bars close to the bending face. You want those rebars close as possible without having other problems to that tension face of the concrete. And that imparts a lot of strength. So that's a big functional difference of reinforced concrete versus reinforced block. We can control where the bars go and add a lot more strength to the concrete. A concrete beam, a concrete grade beam, there's a reason why the bars are at the bottom or near the bottom, because the beam's bending like this. Concrete, when it is in tension, it snaps. But we put the bars there so that when just before the concrete breaks, it engages the steel stretches, and that's why reinforced concrete is amazing, really an amazing thing. Block doesn't have as good as properties of engaging its bars. Oh, so, all right, now for you, additions. When is it a problem? You know, I talked about some expected behaviors or some predictable behaviors that aren't really structural problems. Okay, well, we have 100-year-old masonry box and a 20-year-old wood siding box. So what is the context? Do we have that situation where they're just sort of behaving thermally differently? You know, what does the addition look like? Is it all glass and glazing? Is there functioning HVAC in it? Is it just thermally doing its thing? Is that why it's cracking? Or is there corroborating evidence? Does the crack where the addition in the house meets, is it nice and straight and hairline? Or is it this lovely, clear V-shaped crack that says, okay, this is pulling away, this is moving? The simple thing is it a shallow addition next to a house with a basement? To us, that's a huge factor. I mean, sometimes we discern that before we're on the property. It's like, okay, well, look at the street view. This is a little addition and the house definitely has a basement. All right. Do we have to look to see if it's an addition that's settling into the backfill? So that's what I encourage you all to look for. Look for the context. Look for that corroborating evidence that says, okay, is this normal? Is this not normal? And when in doubt, give me a call. Yes, or email me pictures, please. Email me pictures. I love pictures. I don't have cards with my email address to give you today.
We do have another audience. We do have a question from our online audience.
Yes.
Mark wants to, and I think you touched on this a few minutes ago, but he's asking about, don't you find that budgetary concerns commonly prevent engineers and architects from incorporating precautions against future conditions, and when they are done, aren't they just ignored?
Excellent question. Yes, all around. And to some degree, that's why we as a firm do 80% investigations and forensics and only 20% design. Because honestly, and even year after year, it just gets more and more frustrating being ignored, saying, well, Matt, that's too expensive. Why would I do it the right way? All right, short term. We at least have some authority as engineers to say, just really stand behind our stamp and stand behind our license to say, see that drawing, see that stamp, this is what you do. You don't do this, I take it up the chain to the permit office and tell them you didn't do this. So that's something that we keep in our back pocket in those cases where we really need things to be done right, come hell or high water. Yeah, so it's frustrating, it's a real concern, it's a valid concern, and we fight it.
Now, here's a more general question. When, say, we see an issue in a house, like a CMU foundation wall, and it's got a horizontal crack, and I can put my business card in the crack, and that's usually, my understanding is that's when you have to really start worrying about it. So you can put your business card in a horizontal crack, that's something that needs to be looked at. At what point you would say call a foundation person versus a structural engineer?
Well, at what point do we call a foundation person instead of a structural engineer? I have a very biased response to that question. Very biased. Let me answer it this way. I am, as a independent expert myself, I am a proponent of independent experts. I am a proponent of independent experts. I always feel foundation repair companies, I mean, you always have to take that with a grain of salt because they are repair companies. I've received so many calls in this past year from people who called a certain foundation repair company with 3 initials as their name, who are so unhappy. Matt, they sent salespeople out. They saw a crack in the foundation wall, and now they're forcing me to get a $20,000 drain and sump pump. What does that have to do with this crack in my foundation wall? It's like, well, I'm glad you called us because I'm not here to sell you. I have to answer. Call an independent first. I really have to answer that. Even if it's not us. There are other independent structural engineers out there that look at homes. Call someone who is not vested in a repair company. I have to answer that way. Before we move on to, I guess, interior spaces and changes, any specific questions about additions?
There are a couple words I didn't hear: expansion and contraction and old house charm.
I love old house charm. I really do. Like, I really
use
do.
that.
Give me 100-year-old row house where it's a fun house. You walk uphill, downhill. It is character. It's great. I love it. I love it. And it's hard to convince new homeowners who have bought a 100-year-old house that you're looking at 100 years. This house is older than you. It'll outlast you.
Undulation.
Yes, yes, absolutely.
You have to want to live in an older home.
Yes.
I think any structural repair recommended should be done under the guidance of a structural engineer.
Yes.
That's the way you get around, who do I call? And so, it's gonna be a carpenter fixing it, but he ought to be doing it through some plans that an engineer.
Yeah, I mean,
Guidance.
yeah, because I always tell my clients that if it's gonna require drawings, you need an engineer.
So I know we are running out of time. So, all right.
Okay.
Let me, I guess, open it up to, I guess, general, but instead of getting into a brand new topic, because we've actually covered a lot, and some of the later things, changes to interior spaces, excavation problems, we've actually touched on a lot already. Oh, no, I take that back. There is something I have. Yeah, there was cats that I under a deck. I didn't know. I looked at my camera. Oh my God, why are there green eyes staring at me? Okay. All right, I do want to touch on this one because this one's important. There are, as a structural engineer, there are a few things in homes that scare me. This is one of them. When we have anybody can guess what's under the black plastic?
Bench foot.
Dirt.
Yeah.
Yep. It is dirt. It is only dirt. It is this. It is dirt. It is this vertically cut dirt. The footings are up there. This was a crawl space. This was a crawl space this big. The footings were up here. Under the black plastic is just dirt. The homeowner informed me that not a week before my arrival, there was a spot here where mud was coming through. Great. Yeah, exactly. We'll put plastic over it. It's
Structural plastic.
structural plastic.
Yes.
Slap some carbon fiber on the dirt.
Please, if you see dirt, if the footings are up here and you see the sheer vertical excavated cut face of dirt, please call someone. It is bad. It is really bad. It's terribly bad. All it takes is one clogged downspout, one overflowing gutter, one winter. Yes. And that dirt can just push. Yes. It's really, really dangerous. Yeah.
What a lot of people don't realize is two things can liquefy dirt: water and vibration.
Vibration, yes. So, and the homeowner was like, "Oh yeah, someone told me this was perfectly fine." I was like, this is the opposite of perfectly fine.
Yes.
So, but he said, "But there's nothing else going on. There's absolutely nothing else going on." Oh no. The brick on the outside, you can't really see it well, but there is a very large crack here. There's another very large crack here. It was already showing signs of failure and movement. This was serious already, even though it was relatively cohesive looking dirt. Here's another example. Over the past 20 years, I'm fortunate to say that I have had to condemn very, very few houses. I can count the number up on one hand. I've seen hundreds of homes. This was one that I had to condemn. This was a DC row house. So not only was her property in trouble, both sides were in trouble. So The city, so we wrote a letter to the neighbors. We alerted the city, we put the homeowner in contact with the city came out. What you can't see in this picture in the back, it is mud. It was mud. There was, I'm sorry? Oh,
The back
yeah.
wall looks flat.
It was-
The side wall.
It was terrifying. Like, and we received a call. It's like, oh, there's some foundation issues. Look at. I went down. My jaw hit the floor. Like, it was okay. Let's talk outside and go from there.
But let me get a quick picture before I go.
Yeah.
Yes. Well, I took a lot of quick pictures. So, I mean, this was now the only saving grace here. This wasn't the entirety of the basement. The front half was a full basement. There is a full height basement wall here, but then my guess is the back half was just a crawl space, and someone decided to just dig it. But this was terrifying, and this was in a neighborhood that was undergoing a lot of redevelopment, a lot of fixing up. You know, the houses on either side, they looked lovely, had little kitschy stuff on their front porch and little twinkle lights in the windows. And oh my God, this is terrifying to me. So please, if you see this, if you see anything that resembles this, call somebody.
Is there any way to remediate that, other than basically filling that with concrete?
We can fill it in. We can get a soils engineer to, instead of concrete, we might be able to do it with gravel or compacted fill. So there are soil options. From a structural standpoint, this is like immediate underpinning, which is an oxymoron because you can't do underpinning immediately. So this is temporary support. This is jacking up the house. This is stopping the darn thing from collapsing and then getting the underpinning moving as soon as humanly possible.
Do you know how long it was like that?
She said for years, but that the water was new, and that's what prompted her to call me.
I'm curious, everything in my training has, I've been encouraged to not react emotionally to things like this. And was this occupied? Was this house occupied?
This was not occupied.
Not occupied. And I'm kind of throwing this out to the floor. Let's say this house is occupied. My reaction to this is to say, this needs to be addressed immediately. Do I say anything at all like, you need to get out? Yes.
Oh, yeah, oh, yeah.
Okay.
It's a safety issue.
Our mentor from years ago, JD, was in a house like this, walked downstairs, took one look, and said, everybody out of the house.
Now.
The last person walked out was followed by a cloud of dust. It collapsed as he left.
Wow.
Wow. That's one of his favorite stories. Because somebody, row house in Georgetown, where you have the little tiny trash walls between them. Somebody decided to dig that trash wall out and put a conduit in there. So they basically removed the footings from the two houses, and both houses went into the trench.
So there are extreme cases where all the training goes out the window, everybody out there.
Occasionally, I'll walk under, I went in a crawl space and saw what I call the Jenga pair.
You can present it better. If you're not the first guy out running,
Yeah.
and you make sure they get out safely, that's a better way to present yourself.
Yeah.
Very true, very true.
You know, like occasionally we'll walk it, I will not walk a deck before I've been underneath it. And sometimes I won't get on the deck after I've seen what's underneath it.
Well, thank you very much. That was very
Thank you.
informative. We appreciate it.